In this video, we're going to go over the Module 4 Day 2 activity from Friday, October 4th, the acupuncture exercise. A couple goals. I want to go through the import process again and point out some key things that can lead to errors. Also want to kind of walk through the code and just point out a couple of things and do it in detail and deconstruct what's happening with some of the code. I'm not going to discuss the answers to the exercise in terms of the interpretation. We'll provide that in a key. But so let's go ahead and start. And the so the first thing we need to do is get a project started and get our data loaded up. And again, the projects are helpful because they do a lot of things in the background that just kind of make your life easy. And so it takes a little bit to get them set up, but it's really worthwhile if you're going to be doing any amount of analysis on a particular data set. So, and as we've suggested before, there's a couple different ways you can go about. You can use the new directory option or the existing directory option. So let's talk about those for a second. So in the new directory option, the recommended kind of path for getting things started is to start a new project in RStudio using the new directory option. Once you do that, RStudio is going to create a folder and associate a project with it in your operating system, and then you can actually get the needed files, put them in this newly created folder, which is just a directory. And usually that's your script files, your data files, which may be a CSV file, which is the case for this project that we're working on, this activity, or it may be an R data file, which is a data object saved from within R that R recognizes, and so you don't have to import, you can just open it. And then you're ready to rock and roll. Okay. The other way to start a new project that we've talked about is to use the existing directory method. So they're equivalent in terms of what once they're set up, they're exactly the same. It's just a process issue of whether you have a folder that has your files in it already, or you want to do that first, or you want to create the project and then put things in there. So in this path, we put the needed files in a directory that you already have on your hard drive, or put them in a new directory that you've created, not inside of RStudio, just in your operating system. You download the files, put them in a folder. Then you go into RStudio, start a new project, choose existing directory, and point it to the directory where you just put the files. Okay, now you're ready to rock and roll. So let's go ahead and take 1 second and let's point out a couple things. So having some issues here. Get my folder set up. So here I am in my browser looking at the website, and I've got these 4 files that we have: the assignment file, the slide PDF. So if I go ahead, and I've already downloaded these, but when I click on these, let's click on this one and see what happens. So I'm in Chrome. So notice that it's saving it. Now when I go a highlight, look, it saved it as acupunc_rct_vickers, and then when it does the rollover, it's got a 2 in parentheses. That is not what I want, because when we get to the script file, you'll see that it wants to see this file name right here. So let's open up my downloads folder and let's see what's happened here. Okay. So the problem is that we've used this. I'm going to move this over here as well. I've got 2 folders open here. One is where I store my files. Over here is my downloads folder. Here's the file that just got downloaded. Okay, and here's the problem, is that we've used this before. And so that file, look, there's the one. Here's the original one here. The second time I downloaded it, it put a paren1, and this time it put a paren2. So it's already messed up the process, because I need the exact file name if I'm going to use my script. So I'm going to get rid of some of these. And notice I've got multiple versions of the script file as well. So that's something to watch out for, and we'll come back to this in a minute, because we need to have, when you run the scripts that we send, the file names need to be exact. So one way or the other, we've gotten, I have an Acupuncture CIs project folder, and I've saved the CSV file. I've got a project file there, which RStudio creates, and then I've got a script file. So let me go ahead and go into RStudio real quick, and let's fix this up a little bit. Change the resolution on my screen so you can see better. So let's see if I can get this to display correctly. There we go. All right. Let's get these guys. Okay, there we go. So now let's go ahead and go over here and do new project. And I'm going to do new directory. And I'm going to, I've already got a file there, so I'm going to move up one directory level just because there'll be too many folders. And I'm going to call this Acupuncture CIs. Okay, so we got to create the project. Now it's on my files pane. I'm in my new folder. So let's take a look at what's happened here. So here's the folder that I just created from within RStudio. So now I'm going to go into that folder. I'm going to grab all of these script files, and I'm going to drag them all in here. Actually, I don't want to move them. I'm going to right click and copy here. So I brought along also the Word document and the PDF, the script file and the CSV file, just storing everything together. So now let's go back to our slide set here. Give me 1 second. Okay, so now I've got everything in the folder. So now if we go back into our RStudio session, we are going to see, let's go ahead and do that. There they are. There's all the files that we had. And so we've created a project, put the files in it. And so now we've got our files in there, we've got our project, so now we want to open the script file. Now there's two ways we can go about opening a script file. One is if we just go to the file pane, we can simply, because it's a .r file, RStudio should recognize this as being an R script file. It's got the little R saying it knows what it is. So if I just click on that, it opens up the file, and I can see what's going on now. There's my file. Okay. Now the alternative way to do this is to go to File, go to Open File, and notice that it defaults to the project home directory. Now I can simply click on the script file and click Open. I'm not going to do that because we've already got it open. Let's go back to my slide set here if I can get back there. So here's the alternative method of opening the script file, and then we click Open. And so now let's talk for a sec. So now we've got our project, we've got our script file and our data file. So now let's talk about what we need to do, what this code is going to do. Okay, so the summary is, so first we're going to import the CSV file into RStudio. Then we're going to split the original data set into two separate data sets. One data set that has all the variables from the original data set restricted to just controls. We're going to call that control. The other is going to be called treat, and that's going to have all the variables in the original data set restricted to just those in the acupuncture arm. Once we have those two new data sets, we're going to restrict them to just those subjects with headache severity measurements at 12 months, because that's what they did in the manuscript, and we're trying to kind of closely recreate what's going on there. Then we're going to calculate 3 95% confidence intervals, one for the mean headache score at 12 months. So that's a confidence interval for a single mean for the acupuncture group. We're going to do the same thing for the control group. And then we're going to calculate a confidence interval for the difference between mean acupuncture and mean control headache scores at 12 months. And I've left off here, there's one last thing that happens in this file. There's some histograms that get calculated, and there's a second set of confidence intervals, and I will talk about those, but I didn't include them in this slide here. Okay, so running script file code. So here's our script file, and so let's look in detail at some of these things here. So one thing, remember that green means comment, right? So green color code indicates comments. Any line preceded with that starts with a number sign will be turned green and considered a comment by R and not processed when code is run. So I generally tend to put double number signs, but that's just a thing I do. That's not required. A single number sign at the beginning of a line, or actually anything that's preceded by, you can put comments in the middle of a syntax line, and everything past the comment will be coded green in RStudio and ignored by R when it's submitted for execution. Just a reminder, comment is an extremely important practice. It adds time to coding, but so in an individual session it takes more time to add comments, but when you come back over the lifetime of the project, it really does save time, and it makes for more reproducible analyses. All right, so let's actually walk through the code now. And so there's a couple of ways. We have a CSV file here. We don't have an R data file. So since it's CSV, we need to import it. We can't just open it. So as we've done before, you can use the import dataset button shown here to get the data set in. Right? Now, if you do it like this, there's a couple things to remember. One is, so you're seeing up here, this is the name of the file. You can change the name here if you want, right? But for our purposes, you don't want to change this name because, or at least let me say that you need to be careful about changing this name, particularly if the script file references this later on. So you want to be a little bit careful with that. Also, very important, heading needs to be yes usually, because usually the first row of the file is the variable names. If you say heading no, which it'll default to, then it will make the variable names observations of your data set, which will mess everything up because they won't be the right variable type. Instead of numbers, they'll be numbers and this ID. So you need to pay attention to the options here, right? So if you click heading yes, now we see that the bolded names are correct, and now it's interpreting the data set correctly. Okay, so that's something to watch out for when you import the data set. Now, the other way that you can read in the data, particularly when we distribute a script file to you, is using actual code, because in the console, the import button that we just talked through will actually generate code that looks something like this when you press that button. So let's look at this syntax and what's going on here. So we have a couple of parts to this syntax that are important to acknowledge. So first, data. The first thing we've done is we've named the object. This is a name we choose. This is not a name that R needs us to provide. It's not part of a function. It's just what we want to call the object we're importing. So because we have a script file we've distributed, it is going to play off this data name. So you definitely want to not change that if you're working with scripts that we've provided. So the script, the R command that's being used here is the read.csv. Notice that the arguments to this command, I always try and put parentheses here to indicate that the arguments go in parentheses. So the argument of this command goes inside the parentheses. It needs to be in quotes, and the one key thing is that this file name here needs to match exactly the file name that's in your project folder. So before, when we saw that Windows renamed the file when it downloaded it because it already saw a file in my download folder, you need to make sure that the file name in the read.csv statement matches exactly the file name in your project folder. Caps, everything. Everything has to match. Okay, so that's our first line. Remember that R, a couple notes, R is case sensitive, and we already talked about the file name matching. Okay. So let's look at the next bit of code that we have here. So now that we've read the object in, let's go to our file. I'm going to go ahead and read this data in. I'm going to select run. So now we've got our data object, 401 observations of 94 variables. Now the next thing we're going to do is run this control and treat code. So let's talk about what this code does. Right? So control and treat, again, are names that we've selected to give these data objects that we're creating with these R commands. So subset is the key command here that we're using in these two lines of code, and this allows us to subset a data set. We have two arguments here. The first argument is the data set that you want to subset or operate on. The second argument is the criteria you want to use to subset the data. So group here And notice in my notes, it's PowerPoint is capitalized. Remember, everything is case sensitive. So group in the actual variable group is a small g. It's the treatment arm variable in this data set. It has two values, 0 for control and 1 for acupuncture. So when we're saying group equals 0, we're saying we want to take the group variable in the data, we called it data, the data set, and we want to take all values of group that have the specific, that have a 0, right? So that the first line there subsets to the control, the second line subsets to the treatment. Okay, so let's look at the next piece of code here. So we can run these. Now we've created a control and a treat, 196 observations for control. Notice all the variables are still there. 205 observations for the treatment or the acupuncture arm. So let's slide down, and we've got two new pieces of code that we're going to run here. So let's take a look at those. All right, so let's walk through this. Again, on the left-hand side, we've used a rather complicated naming convention, and that maybe arguably is not the best, but it is descriptive in some sense of what we've done. We're creating data sets that have only complete cases for PK5 at 12 months, or headache severity at 12 months, which is the PK5 variable. So we're gonna subset again. So we're using the subset command. And now the two data sets we're operating on are control and treat. And the second argument is the criterion that we want to use. And we're using the is.na function here. So let's talk for a second about is.na. So is.na is a function that returns false if the data point is observed, and true if the observed value is missing, or i.e. na. So what we're interested in doing is we want to select the observations where is.na for control headache severity scores at 12 months is false. In other words, we want to restrict the control data set to individuals who have an observed value for headache severity at 12 months. And we want to do the same for the treatment group, right? So we're subsetting to a complete case analysis. And so that's what that command does. Let's go ahead and run that code really quickly. So we've run that. So now we've got two new. Now remember, so treat has gone from 205 observations down to 161. We still have the same variables. Control has gone from 196 to 140. So we've deleted quite a few variables. So the next step is unnecessary, and I could have started with this, but I just wanted to show the renaming, I guess. So let's just rename these so they're easier to type, right? So control_cc, control complete case. We'll just reset that to something that's not quite as long. That's all we're doing there. So let's run that code. That's not going to do anything except create a couple of additional data objects down there. So now we've got these two match, control CC and control no miss, and treat CC and treat no miss are now the same. All right, so our next bit of code, we're done actually, right? So now we have complete cases. We've created two data sets, one for treatment and one for... So we've got the data in, we've manipulated it, it's ready for analysis. So let's move on to our t-test criterion and talk about what's going on in these. All right. Okay, so let's talk about the two confidence intervals for treatment and control. So the t.test function does several things. It performs a t-test on the data that you specify, and it calculates a 95% confidence interval. As we've seen already in class, it provides multiple related statistics in the output to these two things, to the t-test and the confidence interval. We're not going to talk about the t-test now. We'll talk about that later. So a couple of notes. The first argument in the t.test function provides the data set and variable of interest. Now, it's going to be a little bit different when we have more than one variable of interest, but here we just have one because we're doing a confidence interval on a single mean. The second argument var.equal true tells R that we want to assume the variances are equal. This is one of the assumptions of the confidence interval and the t-test. It's essentially the same assumption. And note that if we didn't specify this, the reason we're doing it is because R defaults to variance.equal false. And so for the purpose of what we're doing right now, we want it to be true. Notice that, and I'll talk more about this in a minute, since there's only one mean here, it doesn't make a lot of sense to talk about variances being equal. So technically, var.equal true and var.equal false will give the same result when there's a single mean, because there's only one sample and one standard deviation or one variance, right? So we'll talk about it. It really comes into play when you're doing the two-sample t-test. So these are the only arguments that we need for this. There are additional arguments in t.test, but we don't need to specify any of them for what we're doing here. When doing analysis, it's always a good idea to look up the help for the function that you're working with to see what the defaults are and make sure there's nothing else you need to set. Okay, so now let's look at the output from these two functions. So the again, as we said, this is identified as a one-sample t-test and confidence interval for a single mean, because we just have the one data set, the one sample we provided. So up here, these t, df, and p-value are associated with the t-test, so we're going to, and the alternative hypothesis, so we're going to skip this for now. We'll come back to this. The 95% confidence interval is provided. The lower confidence limit is 14.11. The upper confidence limit is 18.38. Notice it also provides the point estimate, which is just the sample mean of 16.25. Similarly, down here we have a confidence interval from 19.5 to 25.19 or 25.2 with a mean of 22.34 for the control group. So the mean and confidence interval for the treatment is less than that of control, and we know that smaller headache severity scores are better here. So let's talk about the third confidence interval, which is a slightly different. So let's look at our notes here. We have two data arguments, so this will be a two-sample t-test. The first data argument is the treatment complete case headache severity at 12 months, and then control. So we just list those together as separate arguments, and then we have the var.equal true argument again. So here the var.equal true has a little more meaning in the two sample case, because what we're assuming are the variances for each of the headache severity scores, and the controls and the treatment have the same estimate, or assume that the variances are equal. And what that means is that when we calculate the standard error that we're going to use to form this confidence interval, that we're going to use a pooled variance estimate. So it's going to use information from both samples, assuming they're equal, and so that implies a specific formula. We're not going to go into the details of that. You could calculate this under var.equal equals false. This tells R that we want to assume the variances are unequal. So it will use an alternative form of the t-test, an alternative calculation. Again, again, we'll talk a little more about this when we get to the t-test. So here's the output from the two-sample, the confidence interval for the difference in means. It looks very similar with t-test. This is a two-sample t-test now. Let's skip all that. So our confidence intervals down here, it's minus 9.58 to minus 2.61, and it's provided the sample means that we saw before in the individual confidence intervals. We're subtracting control mean from treatment mean here. Lower score is better. That means that negative scores favor treatment, right? So we're subtracting control, which is higher or worse severity, from the treatment mean, which is lower. So what this interval tells us is that all plausible values of the difference between means are negative, right? Meaning that treatment, all the plausible differences in means favor treatment or acupuncture regimen. So now the other thing we need to do is really think about the magnitude of these differences and whether they're meaningful or not. Notice that the estimate that the point estimate of interest is the difference between these means. So this can be calculated, just by entering at the console the actual values that they're provided. You can also do it in a more formal way so that you're not typing in numbers. But the mean difference is about 6.1 in favor again of treatment arm. Okay, so that pretty much gets us through the most of the code, and here we can just run it and we'll see that we have the same output. There are a couple things left here. We have a couple histograms that relate to one of the questions, and then there's a bunch. This all should not be here. I didn't intend for that to be there. That was some additional work I was doing, and I uploaded the wrong file. But so also there's a bit of a mistake here. This is not t.tests, it's t.test. And so let's talk a little bit about these really briefly before we close. So again, just reviewing, here are the histogram syntax here. This is a function that calculates a histogram. As you know, there are 3 arguments for each of these commands here. The first specifies the data set and variable of interest. So here it's Control CC, complete case PK5, so headache severity obviously. The main option simply specifies the title that you want to put on the histogram. And the third, the XLab, in again single quotes here, is the label for the x-axis or the variable axis that you're primarily working with. So we have the same X label for each of these histograms, and we just want to change the title and the data to match the groups appropriately. So what we get is we get histograms for each one, we get the control group heading here and treatment group here, and then the same labeling. Okay, the last thing. All right, so we've got two more t-tests, and we're just going to show briefly this. We'll talk more about this in class. So here, the first and second arguments provide the data set and variable of interest. So we have in the first t.test function, we're looking at PK1 or baseline headache severity scores in the treatment group compared to 12-month severity scores in the treatment group. So that's looking at a within-group difference over time of how did scores compare between baseline and 12 months. We've put the var.equal true option here. And so this is really similar to the syntax we've used for the difference between means. So really this is doing a confidence interval for the difference between means within the same group over time. The second formulation here is looking at the same variables, but we've got a new option specified here, which is paired equal true. We'll talk a little bit about that in class because, in a sense, we have the same subjects being observed over time, and we'll talk about why pairing is appropriate here. So the question of interest is a two-sample version of the t-test and confidence interval appropriate when you're looking at the same subjects over time within groups? Does that violate any of the assumptions that we've talked about for the confidence interval? And the second function performs a paired t-test and corresponding confidence interval that we'll talk about. And the output, let me show you the output here. The output is the first is going to be a two-sample t-test as we've seen before. We've got a confidence interval for the difference between means and mean estimates. Noticing that at baseline in the treatment arm we had a mean headache severity of 24.6 approximately, and it reduced to 16.2. And we've got a confidence interval for that difference of 5.2 to 11.8. Notice that here we're subtracting the 12 months headache severity from the baseline, which is why these are positive, right? So we started it higher, so this is indicating that the plausible value for the difference between baseline and 12 months are all positive values. Again, this indicates that there was a reduction since 12 month is lower, and lower means that there's an improvement. In the second case, we have a paired t-test with the paired equal true option. We'll skip the t-test stuff. Here the confidence interval provides a confidence interval from 6.35 to 10.31 and a mean of the differences of 8.3. So we'll talk a little bit more about what's going on with this case. The confidence interval is different, the estimate is different, and we'll talk about what the differences are between the two of these. But I just wanted to show what's going on with these. All right, that's really, let's go back here. That's really all I wanted to show. We can do the histogram and run those. We'll get our standard things, and we can run our t-test and get the same output we just looked at. So let's quit here at 30 minutes. My goodness, that's long. Sorry about that. Anyhow, hopefully this was helpful.